My name is Laura Gardner. I am your moderator tonight. I am a librarian in Gardner Public Schools, and I am also a climate activist. And so first things first, some housekeeping. I want to thank the last round and staff. So please remember, they open just for us on Tuesdays once a month, and we're so grateful. So please drink and eat. This is our way of repaying them. So this evening, our guest speaker is Rob Hellström. Rob is a professor of geography at Bridgewater State University, and he has spent a lot of his scientific career studying microclimates. He's done so at the Harvard Forest, along with the Peruvian Andes, as well as in New Bedford, using citizen scientists from Youth Opportunities Unlimited, some New Bedford students. And so, yeah. So tonight he's going to talk a little bit about the research that he's done, and his topic specifically is microclimates, how climate change is influencing local weather. So please welcome Rob Hellström.
Thank you, Laura, for that fantastic introduction. So I got I think it was an email from Laura, and she said, hey Rob, do you want to give a presentation to a group of enthusiasts of science at a pub? And I said, yes. So I'm here. I'm happy to be here. It's a pleasure to be here. So I have a script I'm going to read for a few minutes and then open it up for questions, of course. Like Laura said, I'm a climate scientist. I have a... Okay, can you hear me now? Excellent. I'm a climate scientist, and I have a degree in meteorology and a degree in aerospace engineering. That's how I started out in engineering, and then I just said I didn't want to sit in front of the computer all day. And I couldn't get a job in engineering because the changes in the presidency and so forth. But I went into atmospheric science and at Ohio State, and I studied that for about 6 years. I got out of Ohio State and I got a job. I got 2 offers, one in Saskatoon, Saskatchewan. Hey, we got some Canadians here. and one offer at Bridgewater State College at the time. And so I decided, well, I told my girlfriend at the time, I said, hey, what do you think about Saskatoon? Because I was excited about that one. And I had an interview in December at Saskatoon, and got off the airplane, and it was negative 40 degrees. Who cares? Fahrenheit, Celsius, it's the same thing. It was beautiful. It was just perfect for me. But the offer from my wife wasn't that great, so I chose Bridgewater. And I've been in Massachusetts now for 25 years. I very much enjoy this area. I enjoy sailing in Buzzards Bay. I live in Fairhaven. It's just a great place, great community. But there's a lot of stuff going on here, right? So, yeah, I scripted this. It's a bad idea, right? So, have you ever driven just 10 or 15 minutes and then suddenly the weather is changing? You know, or, sometimes as you drive towards the coast, as I used to drive, now I take the train, but I used to drive from Bridgewater down to the coast on a spring day, and in Bridgewater it'd be 80 degrees, and as I approach the coast, the temperature just drops, and then the fog rolls in. Well, what I'm trying to get at is that's a microclimate. That's where we live. That's what fishermen deal with. It's what our local community has to deal with. And as you move around Massachusetts, there's quite a variation in climates. We all know, okay, we got 1.5 degrees of warming or so Fahrenheit over the past 100 years globally. But did you know that at the Blue Hill Observatory, which has the longest record in the United States, using the same instrumentation, has warmed by 4 degrees Fahrenheit? And so that also is microclimate. It's, you know, the amount of warming depends on where you are. And as many of you probably know, the Arctic is warming much more rapidly than the rest of the globe. In fact, about 5 times the rate. Where I've worked in the Andes, in the high mountains, the warming is about 3 times the rate that we have at sea level in the high mountains. So unfortunately, that's where the water towers are for millions of people, known as glaciers. And these glaciers are experiencing a much more rapid warming than at lower elevations. So that's one area that I work in. And you know that's microclimate. It's kind of like a local fingerprint on climate change. And it's important because if you understand what's happening locally, then you can have action, proper action. Let's see what they got here. So microclimate is simply a small, localized climate. It could be as large as a bay or as small as a park, your local park. It could be a hillside. It could be a city versus a suburban area. It could be a city block. Some parts of the city are much warmer than others. So elevation is also important in microclimate, and that's one thing I'm a specialist in, studying what's called elevation-dependent warming. And that's something that is studied around the world. It's not just me, but there are many scientists that are concerned about higher elevations in Europe and in China, in many mountainous areas, because many communities depend on those glaciers from those high elevations. And there's plenty of water now, but what will it be like in 50 years when the 0-degree isotherm, the line of 0 degrees, is going up these mountains at a rate of about 100 meters every decade. And you run out of mountain space at some point. And so that local impact is accelerating the 1.5 degrees that we see globally. So there are these local instances that are important to study. Yeah, I'm a sailor. Any sailors in the room? Okay. So I have a 30-foot sailboat that I got pretty cheap and fixed it up. And my wife and I go sailing on Buzzards Bay. And if you know anything about the winds near the coast or on Buzzards Bay, they can change very rapidly. Again, another example of microclimates. I think it was a couple years ago, we had a bunch of southeast winds that came in and dramatically changed the shoreline. When I walk my dog down to the beach, for example, I see dramatic changes in how the sand has moved around, and this impacts the aquatic marine systems near the coast. Or take coastal flooding, right? Sea level rise. That's something that we have globally. Why? Because if you warm the ocean, it expands, but also the things like glaciers and the ice caps are melting. So that adds to sea level. In Boston, over the past 100 years, sea level has risen about 2 feet. But the projection is, with kind of a ramping up of the temperature, and higher temperatures in the deeper oceans. The more of the ocean that we warm, the more it's going to expand. So by 2050, we could expect another 2 feet, potentially, of sea level rise. Well, that's only 30 years. Wait, 100 years? You see this exponential rise. And how many of you have ever been there, have lived here a long time and came, walk down to the coast and notice some changes? All right, let's see if you raise their hands. Yeah. right? The nuisance tides, like the boat ramp where I'm at in Fairhaven, Seaview Boat Ramp, very popular place for fishermen to go, and frequently the nuisance tides come up and flood that area on the king tides. And so, of course, they repaved that parking lot about 3 years ago. Did they raise it? No. Which is probably a good thing. We shouldn't be there in the first place, right? But I think you can all kind of think about how your own neighborhoods have changed and how your lifestyles may have changed. Recreation, skating on ponds, and that sort of thing. Going up with a snowmobile, where it was very popular 40, 30 years ago. Now there's not enough snow for that. So that, I guess that can bring me into the next area of research that I've done. It's somewhere in here. And that's at Harvard Forest. So when I first came here in the early 2000s, my PhD work was working in Upper Michigan, not the Upper Peninsula, but Hellström, Michigan, known as the icebox of the nation, which is, again, I like cold places and snow. And I studied there the snowfall and snow melt underneath forest canopies. And I'm kind of, as an engineer, I engineered my own instrumentation, instrumented the area, and I would cross-country ski out to these sites and maybe a meter and a half of snowpack, and observe not only the meteorological conditions, but also the substrate conditions, the soil and the snowpack itself, and how it changes underneath different forest canopies, conifers versus deciduous forest. So anyway, I thought, okay, maybe I can continue that at Bridgewater. And this was back in the 90s when that worked. And I said, yeah, Harvard Forest, and have an excellent program. Phenology, a wonderful place to work. And I spoke to Emery Boost, who's the science coordinator and communications guy there. And he said, yeah, just take a couple sites and set up your instruments. Well, about 3 years into my study, I noticed that there was less snow. And I was working on a model, a computer model, that predicts how fast the snow is going to melt under different canopies. But at some point, the snowpack was so short-lived that I just couldn't get enough data. And so then my buddy from Ohio State, which is where I went, said, "Hey, come down to Peru. We got plenty of glaciers here." And he said, "Well, can you bring a weather station down?" So in 2005, I brought a weather station down to Peru. And then we observed some of the conditions there and this valley wind phenomena, and then we decided, well, let's see what's happening up at higher elevations. So we set up a weather station at higher elevations, and we noticed something quite interesting in that the higher elevations were warming more rapidly. And then we put a string of small sensors that we hung in these polylypus trees to observe the humidity and also the air temperature with elevation. And that's now been going for 20 years. It's very rare, if any of you are former scientists or know about how grants go, it's pretty rare to maintain a network in a very remote area for that length of time. But what we found is that not only the variability in temperatures going up, but the trend is at higher elevations. Lower elevations aren't warming as rapidly. And so we have some clear evidence that can be used in regional climate models, but they can get a more accurate prediction of when the glaciers are going to disappear. So back home in New Bedford, let's take it back here. I'm working with students at Youth Opportunities, Unlimited, and the way I got into that was the former director of outreach there was working at Soul Homestead education center, which is a farm up in Middleborough, kind of in the middle of nowhere, where I had worked with some of my students and some of the younger generation there to learn about microclimates and so forth. Then I got hooked up, and she moved, and she became the director at YOU. And so we've set up a weather station there, and now the youth there have access to weather data in graphic form, is accessible for them. But the most recent thing we did was one thing I loved is flying kites. So I thought, yeah, let's fly kites, and let's put an instrument on the kites. Now the middle school students didn't necessarily care about that part. But what I didn't recognize was there was going to be a squall line coming through while I was flying the kite. And so not only did the students learn about, they use some infrared thermometers to look at differences in temperature, microclimate stuff, but they also learned about severe hazardous conditions. And the student that was holding on to the kite, this is a 2-meter flow form kite. It can probably lift and lift him right up. I grabbed him, and then I grabbed the kite, and the kite proceeded to drag me towards the pond. Now this gets to, this is the warming house down there, and apparently people used to skate on that pond. I don't know if anybody was around for that, but it doesn't happen anymore. We don't get those temperatures. So they videoed me, being dragged towards the pond. Oh yeah, the kite fell onto the pond, which was dry. So you see my story here about microclimate? It's where we live, and it's when we make decisions about resilience, becoming more resilient, we need to understand what the impacts of a global climate change are locally. And I truly believe that if we train our youth to make observations out in the environment, then they can own it. And if you can own it, then you can take action. And I feel like that's one of my passions lately. So I've been reaching out to communities and also, especially middle school age kids, because they're like clay, you can mold them. High school, I don't know. And so I've been having a lot of fun doing that. Let's see, what else did I have here? Yes, let me just, looking ahead. So resilience through microclimate. So what do we do with this knowledge? Well, it means we can track winds over Buzzards Bay, notice how the soils in our forests are changing, listen to the fishermen when they say fog is thicker and the winds have shifted over the years, listen to the farmers when they're talking about their seasons, the growing seasons changing or shortening, or heavy rains that wash away all the seeds that they sowed. Now they have to redo the whole thing again. We need to listen. And most of all, it means we need to invest in our youth. And because the more the students learn to observe, as I was saying earlier, the better prepared our communities will be in the future, our future leaders. So I leave you with this reflection. What skills or knowledge do you think young people need most to prepare for future climates? Think it out. Think you can think about that. Yeah.
So you mentioned growing stations and PG collections. How are the farmers seeing different growing seasons? Are we still in the same 5 or 6, 7 type of book?
I
have to repeat her.
Yeah, so she asked about something I'm not an expert in, of course. As a PhD, I call it piled higher and deeper, and it's true. I only study one thing, but it's a great question. You've all seen the growing season map. Yeah, the question was, how have growing seasons been shifting? are farmers seeing a shift in the type of, crops that they should be growing, something like that, right? And in speaking with farmers, the main problem that I've encountered is that the heavy rainfall, the heavy rain events have been messing with their sowing of seeds and also in harvesting. But I know, from reading about it and so forth, that pests are a big problem now. And so Cornell University has it's called NEWA. It's a network of weather stations that have set up at farms looking at how temperature and humidity have been changing. And so I've started to set up some weather stations that are hooked up with the farming. And I truly believe that, for us to have food to feed everybody, we need to have farmers. And so that's kind of a roundabout way of answering. Yes?
So what is it about the Arctic and higher elevation that makes it more sensitive to climate change?
The question was a really good one. What is it about the Arctic and higher elevations that make it more susceptible to climate change, or that they're seeing higher rates of warming? Well, it largely has to do with elevation, where you have lower humidity values, lower specific heats in the atmosphere. And so if you perturbate that, you force that with just a small temperature change, it's going to amplify because there's just not that thermal mass in the atmosphere. With respect to the Arctic, which it has to do with the fact that in the Arctic, we have this high albedo or high reflectivity surface, and that surface is unfortunately disappearing, especially in the Arctic, the northern hemisphere, where the sea ice. So in the northern hemisphere, it's different from the southern hemisphere. The southern hemisphere is covered by mountains covered by ice, up to 10,000 feet thick above sea level. But the northern hemisphere, it's at sea level and it's a sea ice. And as that sea ice melts, it doesn't reform when it's supposed to. Now we're exposing our planet to a much darker surface. And so it's kind of like, walking on a light colored surface on a sunny day versus a dark colored surface. So the albedo or reflectivity of the Arctic is dramatically going down, meaning less reflective. And so the rate of warming is going to be greater because it used to be this very light covered surface. Yes?
First, thank you for presenting.
Welcome.
I'm curious about diving deeper into your Peruvian study. Have you found any correlation in a change in average temperature and elevation with weather-looking data that is not related to the proximity of a landmass?
I have not studied that yet, but I would say that's a great question to ask.
Because
Yes.
is the atmosphere homogeneous in that warming?
No.
Or is it, as we could expect, subtly influenced by landmass at elevation?
Yeah, so the question is, can we compare what's happening on landmass high elevations to balloon soundings from over the ocean where there is no land? Is the same thing happening over the oceans or in other kind of flatter areas as in mountainous areas? And I know of some studies that have been done there, but I can't quote, what the results are, but it's a fascinating question, right? I think part of it has to do with the landmass itself also.
Sure.
We're losing ice in the mountains, it's getting darker in the mountains, so that's also same as the Arctic idea. Well, it should, perhaps. Yeah, that's a great question.
And if I could go on, because I'm personally invested in issues related to ocean temperature and the impact that even a 1 or 2 degree change in ocean temperature has on weather patterns, because the ocean is known as such an engine for storm generation. We see it with hurricane data all the time. That to me is one of the big, potentially concerning issues with climate change and microclimates when it relates to things like coastal New England and hurricane damage.
Yes, oceans have a tremendous capacity for energy. And if you raise the temperature by, well, first of all, the atmosphere is 1,000 times less dense than the ocean. So, and that has to do with the specific heat. So the specific heat of the atmosphere is much lower than the oceans. So 1 degree temperature change in the ocean is really, really not a good thing. I mean, that is going to be a lot more thermal mass that can be moved by ocean currents and affect, well, the marine industry, but
We've seen the impact in the Gulf, Gulf of
right.
Mexico.
Hurricane intensity.
Hurricane intensity specifically.
Yes, and heavier rainfall.
I know there are a couple of bills in the legislature around protecting trees in urban areas, and I wonder if your research in New Bedford has any implications on, like, or if you've studied the importance of trees for microclimates in keeping cities cool.
Yeah, I have not studied that.
Peter, question.
Yes, the question was urban greening, and planting more trees in urban areas. Can that impact the microclimate? Of course, yeah. And, vegetation cools our planet not just by shading the ground, but there's transpiration, evaporative cooling. It's also an ecosystem service for wellness. Having some vegetation around makes us feel better. So I'm all for it, and that would be a great project for the YLU group to get into. And yes, I understand that there's some push in New Bedford and many other urban areas for planting trees. Yeah, great. Yes, in the back? Okay, in Vermont, they've seen really a drought over the past couple years that's set in, and we know it's terrible this year. Up there, it's very dry. Wells are drying out. Farmers can't, irrigate their fields. And the question is, how many years of that do we need to have to call it climate change? Well, there's 2 aspects to climate change. There's the trend, and then there's the extremes. So when we start seeing ups and downs, whether it's up or down in temperature or precipitation, then that is a sign of a changing climate. If it's unusual and it happens more frequently, that's part of our what people call climate, change. And yeah, so that's a great question. Thank you. Yeah, the question has to do with are scientists finding it more difficult to share information? Well, I'll be honest, I don't have difficulty sharing my data with my colleagues, but what's really challenging is sharing a big database that's now been, kind of hidden away somehow by the current administration with my students. And that's been strange. It's been odd because they've done such a great job of creating graphics that speak to a broad audience, that makes it, accessible to a broad audience. And now I'm kind of faced with just digging into the raw information and recreating the useful stuff, So yes, it is challenging. We do have ChatGPT now. I'll be honest, it's amazing how ChatGPT can take a website that was there a long time ago and kind of pull some of that data together and still show it, but that's not, yeah. I teach climate, I teach meteorology, and I teach sustainability. What a great combination, right? And in my meteorology class, I have a NOAA site that we use, and I ask students to dig into the database, pick a station, and follow it. Look at the trends from the past. And the first thing I see, and I didn't see it because I didn't check it as a professor who thinks it's still there, but my students are emailing me, hey, there's this red thing up here, and it says, due to the current administration, we have shut down the site. Well, that makes it really difficult for me as an instructor to share that information and teach our younger generation about things that are really important we need to consider. In the sustainability class, I used a national climate assessment. I don't know if anybody's familiar. It's a wonderful document, and they recently updated it a couple of years ago. It is absolutely unfound. You can't find it. And so I found it because NOAA had archived the original 50-page report. Well, try giving a 50-page report to a group of undergraduate students, and it's painful. They read it though, because I will tell you this. One thing that's really nice to see is this new generation of students is passionate about making a change. I've seen it over about 5 years or so, and it is unbelievable. And so and they have a very holistic view, the sustainability view, the resilience view, that they want to make a difference. And so that's reassuring. But yeah, so let's talk about positives. The question has to do with, can I take my research in Peru and extrapolate it to what we should do in the Bedford? Well, I can. And it's not like physically you can connect the two. Believe me, that's not right. You can't do that. But I can say that folks in Peru are incredibly resilient. They figured it out. The potatoes are being grown at higher elevations now. Cattle are being grazed up where my research stations are, because the snow is actually receding, but it's also creating a new environment, what's called a paraglacial environment that's rich in vegetation. And I would say that in New Bedford, we have the heavy rain, high rain potential, heavy rain events. We also have some warming trends. And then we have sea level, which is the biggest problem we're going to face. That we need to learn from what the Peruvians are doing, and how they're adapting. They're using nature-based solutions. They don't have access to the technology. And so there are some things we can learn there. So as far as research, I can't really extrapolate, but I can extrapolate the motivation, that community has and that we should have. We should we should learn from these communities and realize that if we care about the environment, we can adapt. But we can also mitigate. There's two ways, right? We can adapt or mitigate. Mitigation hasn't been working very well. Yeah. Last time I checked, okay, to the Bedford rail, we have the rail now, but how many people take the train, right? So resilience, is that's kind of the answer. We should have more vegetation, to have more evaporative cooling, and then also just, vegetation creates oxygen, and it takes in carbon. Right now, this room is filling up with carbon dioxide, because we're breathing. I've done studies with that too. That's interesting. Buildings are the biggest source of energy use, right? We know this. It's the #1 source of energy consumption, and therefore fossil fuel burning. So efficient buildings, more efficiency in buildings, building smaller houses. How about that? So I think I kind of answered the question. Then I have some more. Yeah, good question. The question is, what parameters or what domain do I use to define microclimates? And in meteorology, there are levels of climate that you can study. And in climatology as well. So micro scale refers to something on the order of 10 kilometers or less. So 10 kilometers, 6 miles. So if something changes within 6 miles, it's microclimate, and then less, right? We can walk down the block and you'll notice changes in temperature as well. But then there's another scale of meteorology called mesoscale. Mesoscale is severe weather, on the order of 10 to 100 kilometers in size, so 60 miles, storms, severe storms, tornadoes. And then there's macro scale, that's kind of hurricane size stuff. And then there's global scale, like El Nino. So there are these different scales. And so I consider microclimate 10 kilometers or less, but also, within 100 kilometers square, acting on time scales of seconds up to maybe a day. So diurnals, that's another thing. Night and day. When is most of the warming occurring on this planet? What do you think? Night or day? It's actually nighttime. Yeah, so our nights are getting warmer. And of course, we're not awake to feel that. Well, some of us, unless you're burning the midnight oil. But and why is that? That's because we have more water vapor. And as I said, the specific heat of the atmosphere increases. So it holds on to that infrared radiation that escapes at night, which was heated by the sun, the surface. It's not allowed to escape because we have water vapor, by the way, is the most important greenhouse gas. So we are seeing warmer nighttime, not necessarily more, but longer lived is my opinion on it all. Because there's more water vapor in the atmosphere, those that do happen will have much more potential for heavy rainfall. The question has to do with, is the melting just a linear trend, or does it have step functions? Does it go up and down? The melt, because of the ice doesn't respond very quickly to changes that are rapid. In fact, the ocean probably responds quicker. I would say the answer to that is the thermocline behaves significantly differently and quite more rapidly than the glaciers respond to changes in temperature. Again, I know I couldn't use PowerPoint, but if you imagine the wiggles, right? You all know, and I think I got to do it backwards. Yeah. So this is the past. In the mountains, what we're seeing is El Nino, which is very much related to the thermocline, is in fact impacting the rate of warming, but the ice is not responding as quickly. But it certainly is gaining more, heat from that. So it's not like the ice melts one year. Well, it does melt more rapidly, and then I think that this is a good question for my colleague Brian Mark, who's a climatologist that studies the glaciers. But it's I think yes, the glaciers don't they don't go up and down like that. They respond slowly. But all these perturbations keep going up and up in a trend. And so we have seen the way they study glacier mass loss, one way in the field is to study the stream below, the meltwater. And what we've seen is the amount of water coming from melting glaciers has passed the peak, which means that the amount of water that's going to be flowing in these streams is going downhill, even though the glaciers are melting more rapidly. We've lost so much mass in glaciers. So every one of these little blips that is driven by, a lot of them are driven by the ENSO phenomenon in the ocean. Yeah. Yes. What do you need for a cloud to form?
Dust particles.
Yeah, you gotta have the seeds. So it could also be that there's more, because of a drier climate on land, it could be seeding the marine boundary layer, which could result in more cloud formation. But certainly, the difference in temperature of the water and the overlying air is critical there. Warm water, cold air above, yeah. But that's just my, postulating as a professor. Yeah. Good question. So how do we deal with it? Well, I mean, you got to be prepared. You become a more skilled sailor, and I think that's a great analogy. We need to be more skilled urban planners, because if something is changing, we got to respond to it.
And we use different tools too, right?
Yeah, in sailing, yes. Yeah, we have some great.
Weather forecasting.
Yep. Hyper-sensitive apps that show you how the weather's going to change. Of course, I check that every time. I'll do the NOAA weather radio on my radio on the boat. But to me, that's all exciting as a sailor. Responding. You're sitting there and there's no wind at all. You got to be really patient. But you got to do the forecast. Yeah. The question has to do with, first of all, that I mentioned there's more fog over Buzzards Bay. And that's just my own observations, I'll be honest. So before you tell the Coast Guard, hey, there's more fog, you gotta be here during this time of year and respond to it. We need more science there. But I know that the marine boundary layer is changing, and that has to do with increased water vapor and also differential heating between the ocean and land. Yes, back here, we got a great question. The question has to do with intense rainfall. What's the metric that NOAA uses? So me, guys, is NOAA. NOAA has developed a formula that looks at rain events outside of 99% of rain events. So the top 1% of rainfall over a year, that's considered an extreme event. And that number has been going up, especially since 1980. In fact, I had some notes here on it. There we go. Let me quote what I found out here. So it went from, the number of those events has gone up from about 10% in 1980, we're that top 1% to 30% in 2020. So that's significant. So those heaviest events are occurring more frequently as the years go on. And there's, so it's gone up by 60 events per year since 1960. So 60 more of those events over the past 60 years. So the question is, what does the future look like? Well, in our biggest problem is going to be sea level rise here in New Bedford and around the coast. And as I mentioned before, sea level rise is projected potentially to rise by 2 feet in the next 40 years or so. So that's a big problem. Our kids will still be here. And so to prepare for that, we have to take some action there. As far as temperature, the trend just keeps going up. And as I said, at Blue Hill, we have an instrument that's been used since 1860. The same instrument. It's called a liquid and glass thermometer with mercury in it. Very simple, very robust instrument. And it has been showing that we've gone up by 4 degrees in a period of about 100 years, Fahrenheit. And that's much higher than the 2 degrees Fahrenheit that the globe has experienced. So I imagine temperature will keep rising as well, and more intense rainfall events. Wind is one of my favorite subjects. We have plenty of it, don't we? Yeah. And so Bedford's invested in vineyard wind, and you know, I think that needs to continue harnessing that wind. But also, we should expect more power outages because we have an aging, you know, growth of forests. And so it's clear cut, what, 1950s or so was the last time. But we have heavier rain in the spring, and then high winds loosens the soil. We get trees over power lines. So, you know, that we start burying the power lines like they do in Europe. But the wind, yeah, that's a great point too. Yes. The question has to do, yeah, great. Yeah, the question has to do with we have a warming ocean. We have coral reefs that are bleaching. We have, you know, much lower pH, which means acidic ocean water. And what impact will that have on our marine ecosystems, and hence us, by the way? We rely on that. It's all connected. Certainly it will, you know, but I can't speak to that with a lot of confidence because I'm not an oceanographer, but certainly we need to consider the big picture for that as well. So I haven't gone too far.
That's actually a perfect transition to talk about what's going to happen at our next event, because on Tuesday, November 4th, we're going to have Dale Levitt, co-owner of West Island Oysters, which is an operation located in Nascatucket Bay off of Fairhaven, and Chrissy Pettivas, an aquatic biologist at the Massachusetts Division of Marine Fisheries. And they're going to be discussing ensuring healthy oysters, best growing practices, and the reality of regulatory hurdles. So they'll be able to answer that question maybe. But are there any final questions for our guest speaker tonight? All right, we got one there, so maybe one or two more.
Well, I think he's asking, am I aware of anything other than the striped bass that's being impacted by climate change? I am. I have a buddy who is an oyster person, and his name is Michael Ward, and he has a small oyster farm that is in Little Bay, which is, he lives in Mattapoisett, and he has a nice little oyster farm there. And he has been closed down multiple times, as many of you who are fishermen know, or if you're going for scallops, due to the sewer overflows in the Bedford. And the claim there is that the new metrics suggest that sewer overflow is making its way around West Island, somehow getting back into Little Bay where his oyster farm is. In my opinion, I'd like to see the evidence that that's really happening. And so I wonder where some of these decisions are coming from. You know, a red flag goes up quite in some, yeah, should I?
No.
Yeah, but I'm curious about that because, you know, when I talk to him, it's really, he's going to close down at some point because it's not worth it. So that's my only other thing I can add there, but certainly, yeah.
All right, that is all the time we have tonight, but let's give a big round of applause to our guest tonight, Ron Hellström. Thank you so much for speaking with us. We loved having you at the Science Cafe, so yay.
Thank you all.
Thank you.
Second half, so half a sugar wrap,